This is great fun now. All right, liven things up a little bit before we get to the physics. Well, all right, another projectile problem, and then another kind of home run-ish problem, although the question's a little bit different. We're trying to find the velocity a ball has to leave the bat to be a home run, which proves to be a much trickier calculation than the previous video you might have watched if you're watching them in order. Okay, so what minimum speed does a baseball have to come off the bat to clear the green monster at Fenway Park? So I did a little bit of research on this one. 115.5 meters from home plate, kind of down the left field line, and 11.3 meters high. Assume the batter makes contact 1 meter off the ground, angle of 45 degrees. All right, so I don't think I have to do a diagram for this one. Sorry about that. I'm just adjusting the microphone there. Didn't really mean to cause you any scare. Oh. Someone should stop that person from using the phone. Yeah. Well, let's write out what we have here. We have our final y position needs to be greater than 11.3, so we'll just write it as 11.3. Initial y position is 1.0 meters. In the x direction, it has to be 115.5 meters from home plate. Then we have the angle of 45 degrees. Don't forget, we always have gravity, negative 9.81 meters per second squared, because it's acting downward. All right. So, as some of the other videos you may have watched have done problems like this, in looking for the magnitude of the velocity and you're not given time, you need to do a system of equations. You're going to have two equations, two unknowns. Start with what's happening in the x direction, get a relationship for time and velocity, then look at your equation for your final position in the y direction, and you'll be missing velocity and time again, do a substitution. So it is math intensive, so we'll go through it here. I know you really just can't wait. But that, I didn't mean to push that one. There we go. That's what I was going for. Okay. All right. So in the x direction, the x component is velocity cosine of the angle, and that's 45 degrees. Remember, that equals the horizontal displacement, or the horizontal distance, divided by the time. Let's put the numbers that I know in here. So it's v cosine 45 equals 115.5 over t. Okay. So that equation, remember that, we're going to come back to that one. Now I'm going to write out my y position equation. It's my initial added to my initial y direction, my initial velocity in the y direction, multiplied by time, added to 1/2 of gt squared. Just going to write that out again, putting the values that I know in. So my final position in the y has to be 11.3 meters. Initially it's 1. Now the upward component of the y velocity we don't know, but we're going to write that as the magnitude sine 45 multiplied by time, added to, or I should say in this case subtracted, by 4.905 times the time squared. So now I have two equations and two unknowns. Okay, so here's my second equation. There's my first equation. Solve my first equation for time, put it in my second. So equation 1 becomes t equals 115.5, that's a 5, over v cos 45. Put that into my second equation, so that now looks like this. Sine 45 times 115.5 over v cos 45 minus 4.905 115.5 over v cosine 45. Okay, this marker thing is getting heavy. My arm getting sore here. There we go. Now, if you remember, if you paid attention in class at all or watched other videos, v sine 45, v cosine 45 are the same. Sine and cosine of 45 are the same value. If the angle is not 45, you cannot cross them off. Be careful with that. Yeah, let's try and simplify things a little bit more. On the left, 11.3 equals 1 plus 115.5 is still there, minus, let's see, 115.5 squared is like 13,000 and some, times that by 4.905 is 655,433,920. Oh, sorry, went too far. That is a decimal place, not a comma. 65433.93 over v. Cosine 45 squared is 0.5. Just going to simplify that a little bit more. I'm going to bring all my numbers into the left. So 11.3 minus 1 minus 115.5. Just getting it right in the calculator here. I know. Sometimes it takes a while for this. Hey, what's a negative 105.2 on the left equals negative 65,433.93 divided by a half, 130,867.86 over v squared. Cross multiply, 105.2 v squared equals negative 130,867.86. Divide both sides by the 105, watch your signs, and hit the square root button. Well, when you divide, you should get 1244, about that, and then square root both sides, giving you 35.3. And we get 35.3 meters per second. If that sounded a little bit weird right now, it's because I had to pause the recording and help out a staff member with something, and and I had to come back and then pick up where I left off. So anyway, go through all that. We should get 35.3 meters per second would be the minimum speed to come off the bat to make it over Fenway. That's, of course, if you can hit one of those fastballs. There. So, recap once again. Given initial information, we set up our horizontal component relationship with displacement and time, rearrange, solve it for time, substitute that into our equation for the final position in the y direction so that we have one unknown variable and one equation. The unknown variable is the velocity. And you work it out, and well, great things happen.